Welcome to the Slop Temple. We pray this video helps.
You start by selecting a strong adaptive hash like Argon2 ID, bcrypt, or script so attacks slow down over time. Once chosen, generate a unique per-user salt of at least 16 random bytes using a CSB RNG. This prevents identical hashes. Then set cost parameters, time, memory, and parallelism for Argon2 ID or rounds for bcrypt, tuned to your production hardware. Make sure to document those parameters with the hash output so you can verify and evolve settings safely. You now perform the actual hash operation. Combine the user password and its salt, then run the configured hash function with your chosen cost parameters. Once done, store the username, the salt, the resulting hash, and clear metadata, algorithm name, and cost settings. Make sure not to store plain text or reversible encryption keys in the database, also separate responsibilities. Consider storing keys or secrets outside the user table and use parameterized queries to prevent injection during store and retrieval. You finish by implementing verification. Rehash the supplied password with the stored salt and parameters, then compare using a timing-safe equality. Once verified, grant access. If parameters changed later, rehash on next successful login to upgrade strength. Make sure to enforce rate limits, account lockouts, and multi-factor authentication to reduce credential abuse. If issues arise, check mismatched parameter storage, salt length, or accidental plain text logging. Address those first when troubleshooting to restore secure verification.
Thanks for watching. Consider subscribing if we helped you.